Hello, I am Hassan Nassar and I will be presenting the paper LoopBreaker disabling the interconnects to mitigate voltage-based attacks in multi-tenant FPGAs on behalf of my co-authors Hanna AlZughbi, Gnad, Lars Bauer, Mehdi Tahoori, and Jörg Henkel. So let's start with some introduction about what is multi-tenant FPGAs. So in the recent years, the new FPGAs have enormous amount of resources available. So for example, we have up in the right an implementation of 10 JPEG compression and decompression instances on a ZCU102 FPGA board. And all the needed area for these 10 instances to run in parallel is the one highlighted in yellow. And everything else is still empty. And with FPGAs now being offered as a service in cloud systems, so one idea is to partition this resources because it is not needed by a single user, but to partition it between multiple users. And here, this is the idea of multi-tenant. However, the problem, as we can see from the figure down on the right, is that we will have multiple users and one of them can be malicious and harm the other tenants. Such attacks are already seen in the literature, and this can cause a crash for the FPGA or inject timing faults. And to speak more about these attacks, so on the right, we have some of the blocks used to have these attacks. They are performed by causing a significant fluctuation for the power using either self-oscillating structures like self-oscillation using a multiplexer or a latch, or using short-circuit induction, for example, using a dual-port RAM. And based on the resources used, so based on the number, for example, of the multiplexers used, and based on the toggling frequency of this circuit, so as you can see, in all of them, there is an enable pin, and based on the enabling frequency of this pin, one can cause either system crash or inject faults to a neighboring tenant. And as I said, this attack is already seen in the literature, and there are, of course, some ideas that were done for the detection and also for countermeasure for this attack. So for detection, mainly it is used a time-to-digital converter as a sensor. So with a higher power fluctuation, we have higher delay, and this delay is seen in the output register. And this is for detection. For countermeasures, one possible countermeasure is to disable the clock of the malicious tenant upon detection. However, the problem is that some attacks don't rely on a clock, so it will not be working 100%. The alternative is to have some offline bitstream checking, but this can lead to some false positives and false negatives, and again, some attacks might happen. That's why our solution is needed. And our idea is, as you can see in the figure, we have a reconfiguration manager on the FPGA. And based on the TDC sensors, when it reaches a certain threshold, we trigger LoopBreaker, which actually do a reconfiguration for the malicious tenant. And there is an easy solution for this, is to use an empty bit stream. However, that's too slow. You will see in the results that that's too slow and can't stop the crashes. And for that, we needed actually our solution, which is a custom-made partial bit stream that only disabled the interconnects. And by this, it breaks the loop, as you can see from the figures. And it is extremely fast. However, it required a very complex reverse engineering. So for the reverse engineering, we did it for the UltraScale Plus and 7 series FPGAs from Xilinx. And as you can see, this is the bitstream structure of an UltraScale Plus FPGA. And the bitstream has 4 main parts. We identify these parts and separate them into separate bitstreams. So for example, we can select the malicious tenant but then when there is a real malicious activity, we actually disable it. And building these bit streams needed to take care for the NOPs and the CRCs in order not to have some errors. And yeah, we use the shutdown part to be able to disable these interconnects. And we have implemented this system to test our design and make sure that it is working. So as you can see, we have this large area in orange for the attacker region, and we have in blue the small area as a victim zero slack counters. So they are very sensitive for any faults that will be injected. We have also some noise generators to mimic if there are different other tenants there. And we have a reconfiguration manager. We used Cork, which is an open source reconfiguration manager. And of course, a debugger to be able to analyze what is going on. And this is an overview of all our results. And you can see in the red marked the cases, these are the cases where LoopBreaker performs better than using a blank bit stream. And as you can see, in many cases, we have a 0% attack chance, so no attack would happen. And for other of them, we actually reduce the probability of having an attack significantly. So to conclude, in FPGAs in the cloud, there is the threat of having voltage-based attacks, and the current countermeasures are not enough. And that's why we had our solution, which uses fast disable of the interconnects to have to the stopping of the attacks. Thank you very much.